Right, welcome back. I want to look at numerical differentiation. So in most cases it will be difficult for you to be given a problem with the f of x. Actually, in real life what we have is the numerical data. So in numerical data will show the change of variable over time. Then you're asked to compute, you can then find the numerical derivative using that. So in numerical differentiation we have following points: 2.4 different formula, which is given by f of x plus h of minus f of x. The 2.4 difference formula, this one will be the backward formula. This is minus h. The central, f of x plus h minus f of x minus h. And then the 3-point formula. So the 3-point formulas for first order derivative of this ones will be given 3 points. So for forward difference method, it's minus 3 f0 plus 4 f1 minus f2 everything over 2h. Central is minus f0 plus f2, and then backward is f4 minus 4 f1 plus 3 f2. Now for example, if you are computing the backward method, means that you are applying these two and then the backward. So your f of 2, this will be your point f of 2. So this is your f of 2, and you want to compute, and you want to use f of 1 minus 4 f of 1, f of 0 minus 4 f of 1 plus 3 f of 2. And then the forward difference, you are moving from, means that you are starting from x of f of 0. So this is what we get. And then the central, this will be x1 at x1. So we are using this one plus this one. Take note of that. So as I've said, we are given the value changes of function, the numerical values of that function over their distribution of its values. You are asked to find the approximate of the first derivative of at 1.5 using 2-point formula, difference formula, 3-point central difference formula, and then the 3-point backward difference formula with h is equal to 0.1. So you compare the results with the exact value. So we know that the 2.4 difference formula is given by this f of x plus h. So this is f of x at 1.55 plus x is 1.5 over h 0.05. So f of x at 1.55 is 7.3. So 7.3 minus 6.7 over 0.5, you get the first derivative to be 11.605. Therefore the absolute error is the actual approximate minus actual, which is 0.4008. The 3-point central formula is given by this f of 0. So remember, f of 0 is the value before, which is x computed at 1.4, and then f of 2 is 1.6. Take note, our h is 0.6. 1. So if I subtract 0.1, I get 1.46. If I add 0.1 here, get 1.6, and then substitute by its values there for these two functions. We should have a minus here, and then here we should have a plus. We should have a plus. .67 and then 1.4, it's 5. So yeah, so for this one, these values are correct, but sorry for this one is supposed to be a negative, and then this one is supposed to be a plus. So I'm supposed to have a plus then a negative there. Make sure you correct that. And then the 3-point formula, backward difference formula, so this will be given by this formula, and well, h is 0.01, so this will be given by 1 point this plus 1.4 everything over plus 3 f of 1.5, so this will be this guy minus 4 this guy plus this one is almost correct, and then yeah, and then times 2 times h, which is this guy, and then you should get 11.14. Sorry about this 0.05, I made a mistake there, and the absolute error is 0.0614. Right, so for the second order, or for the second derivative, we use this formula. So those first 6 formulas are used for first derivative, and for second derivative we use this one. So for second derivative, use the central difference method, f of x plus h minus 2 f of x plus f of x minus h, everything over h squared. So if you are given f of x to be equals to x e to the x, and you want to use the central difference formula with h is equals to 0.01 to compute for f of prime of 0.5, so this one will be x plus h, so it will be 0.05 plus h, which is 0.51 minus 2 0.05 plus f of x, which is 0.49. So if you are going to compute this, f of 0.51 means you substitute where there is x, there is substitute by 0.51, you get this, and then this one will give you f of 0.5 this, then f of 0.49 is equals to this, taking these values there and multiplying by the constant this one and dividing by h squared, you should get the approximate value to be 4.121864950. So thank you.